in order to successfully multiply this monomial by the two pieces within, recall that you must multiply each piece separately. X times x is what? And x times 4 is, You want to combine like terms where possible, but can these be combined? No, this is x squareds, and this is x's. These cannot be combined. You've done this when you've multiplied, take for example the number 62 by 3. You multiply the 3 by the 2, just like the x by the x. And you multiply the 3 by the 6, just like the x by the 4. So this is multiplying all pieces, so to speak, by 3, just like up here we multiplied all pieces by the x right there. Now I could write it slightly differently too. I might say 3, that's a 2. How about 2x plus 4 multiplied by 6? Does that change how this functions? Not at all. And I don't really care if you rewrite it, you can. I oftentimes will just rewrite it and make it the way I like seeing it, which is the single item in front of the multi-part item. 6 times 2x. Anybody know? 12x. 6 times positive 4. Yep. 2 got away from me there. Yep. Throw a negative sign into the mix, it doesn't change how you do it. You just have to be a little more careful that you're diligent with your negatives. Negative 3y, negative 4y minus 8. What's the product of negative 3y by negative 4y? What do you think, guys? 12y squared. Good. Negative times negative gave you positive. The last bit, negative 3y by negative 8 is what? Positive 24y. Again, you want to try and combine wherever possible, but these are not the same thing. So the answer is just that. So this was a single item multiplied by a binomial. So a monomial multiplied by a binomial. What if, like in example 2, I gave you a single item multiplied by a trinomial? Instead of having 2 little rainbows, now you'll have 3. The first piece, what's the product there? 4a and 2a squared? 8a cubed. Good. 4a and 3a, guys? Positive 12a squared. Good. Last piece, 4a and 6? Positive 24a. There's your answer. Cubes cannot be combined with squares, cannot be combined with the first. So that's the end of your answer. Now, I only had one variable, the a's, but what if you had more variables? Let's look at this. xy squared multiplied by x squared minus 3xy minus 4y squared. What if I gave you that? Same exact process. First one, x squared and xy squared. What is the product? First, let's multiply our x's. X times x squared is what?
Just an updated announcement. There will be no elementary, junior high girls basketball practice today.
And there's no y's, so it's like multiplying y squared times 1. Give you that. All right? And remember, the coefficient is a 1 for purposes of multiplying by another number. Positive 1 times negative 3 is what? Positive 1, negative 3. Okay, x. Y squared y. Good. 1 and negative 4. X, there's no other x, so it's like multiplying it by a 1. Y squared is y what? See how easy this is? Guys, I really just kind of combined examples 2 and 3 here. Now, your textbook also shows you what they call the vertical model. So I'll do one of those. I always do it this way. Oops, I forgot to write my other little rainbow. If you want to do it this way, you can. But let's say I have a problem that looks like this. 2k squared minus 4k plus 6. And they say multiply it by 3k. All right? Instead of doing it this way, which is horizontally, I can write it up, down, just like you guys do regular old multiplication if you don't have a calculator, and it'll look like this. The 3k, instead of being to the right, which is what you guys usually do, you move your numbers to the right, it's to the left. And multiply. First 2 spots. 2k squared and 3k is what? 6k cubed. 3k and negative 4k. Negative 12k squared, yep. Positive 3k, positive 6 is what? 6 and 3 is positive 18k. Okay, so if you like doing it up, down like that, you can. It's completely a matter of personal taste. It doesn't matter to me how you choose to do it. I don't care. Even if the book says multiply it horizontally or multiply it vertically, I'll never tell you how you have to do it. I want you to do it whichever way feels more comfortable. You're going to always see me do it this way because that was just the way I always learned it. And this was the way I felt comfortable doing it. I don't do this too terribly much. Okay? Any questions before I let you guys go ahead and do your odd? All right. That's it then for today.